Alright, this is your warm-up for the day, so I want you to get a piece of paper and a pencil. You should already have a calculator, your Unit 10 notes, and your homework from last class. And I want you to pause the video and try to work these two problems and see what you get. Remember that with this, the circle, when we have a tangent drawn to a specific point, those things are congruent, and then a perpendicular radius or diameter cuts a chord and the arc in half. It bisects it. So pause the video, work the two problems, and see what you get. Alright, so I'm going to work these out, the answers that, and give you the answers that you should have gotten. Again, this is what we talked about last class. When you have tangents drawn to a specific point, these two segments, or those two tangents, are congruent. So I'm going to set these two equal to each other. 2x minus 3 equals x plus 6. And then we're solving an equation. So I would subtract x from both sides. You get x minus 3 equals 6. Add 3 to both sides, and you get x equals 9. But I want to warn you to be careful because this asked for the length of PR, and PR is this segment on the top. So to find the length of PR, I actually have to plug in the x. X plus 6 is the length of PR, so 9 plus 6 would be what I'm adding together, and you would get that the length of PR is 15. On the second one, this goes with the rule that says if a diameter is perpendicular to a chord, it bisects the chord and it bisects the related arc. This is the chord that has been bisected, 5x minus 6 and 2x plus 9. So these two segments are equal. So I would set them equal to each other. 5x minus 6 equals 2x plus 9. You subtract 2x from both sides to solve. You get 3x minus 6 equals 9. Add 6 to both sides. 3x equals 15. And then divide by 3. And you get x equals 5. So that's just a brief reminding of what we did last class. I'm going to look at a couple of problems on your homework as well. This homework I will check the next time we come into class. A couple of things that I want to point out is these two chords are the same. So this one is 22, and then this one is 22 as well. That makes the arcs the same measure. So if you have arc XY is 110, the arc that is on the opposite of the other chord, intercepted by VX, would be 110 as well. Another one I wanted to point out is number 3. You have a right triangle, which means that I can set up the Pythagorean theorem to find this missing side. You're looking for the whole length PR. This is what it's asked you to find, is PR. But if I could find PS, I know that PS is a radius, and I could basically double it to get this other side. So I could set up the a squared plus h squared equals 17 squared. Solve that. I think you get PS is 15, and then you could use that to find PR. Same thing on number 4. You have the AC is 8, so that means that AB is 4. Set up that triangle. And then number 5 is one of the arc measures as well. One thing that I wanted to point out on number 6 is there's a rule that says that congruent chords, sorry, I should have wrote the word congruent first, are equidistant from the center of the circle. I'm just going to put center. So these two chords will be congruent because they're both equidistant from the center, that 8, and also it's bisected because it's a right angle, so you could use that to find CD. These two pieces are congruent as well. Label the pieces. You know that this is 12 square root of 2, and this one is 12 square root of 2, and then you had OM was 6 square root of 2, which would make OK the same measurement. I also wanted to really focus on number 8 through 13. because this uses some of what we have done in the past with 30, 60, 90 triangles and 45, 45, 90 triangles. If I have a right triangle right here, if this is 30 and 90, this angle has to be 60 because they all add up to be 180. That would make this arc, you see this central angle, open it up to this arc, that would make that arc 60 as well. And then we have this is 12, the other side would be 12 because it's bisected by that diameter that is perpendicular, which means I can set up a 30, 60, 90 triangle. So this is 30, 60, 90, x square root of 3, 2x. That was learned in the previous unit. 12 is opposite the 60 degree angle, so that's your x square root of 3. That's the 12 side. To get back to x, we divide 12 by the square root of 3. That gives you, when you do that in the calculator, that should give you about 6.9. To get the other side, you just take that and multiply it by 2. That gives you about 13.9. So that actually answers a couple of the questions that we have, like EB is 13.9. EB is 12, OB is 13.9. The arc, DB I've already found. The other arc it was asking for was AC, so that was this arc. And I know that if this was bisected, DB and AD are both 60. And then you have this semicircle right here that is 180 degrees. So if I take 180 minus 60, that will give me the arc in blue, AC. AB, you could add both of these together, which would give you 60 and 60 together. And then I wanted to really point out DE, because both of these that I've highlighted in yellow are radii, which means that they are congruent. So if this one is 13.9, then DO is 13.9 as well. I know that from O to E is 6.9, so from E to D, you would just subtract 13.9 minus 6.9. Make sure you have that homework ready to turn in and for me to check the next time I see you, which will be after spring break.